Hello everyone. In this question it is asked that the product we have to find the product of all values of x which satisfies the equation 1 upon x square plus 2x plus 1 upon x square plus 6x plus 8 plus 1 upon x square plus 10x plus 24 equal to 1/5 minus 1 upon x square plus 14x plus 48. Okay, so it seems like there are many quadratic terms here, so let us bring the x squared terms all to one side, okay, and see what we can simplify it to. Okay, so first of all we have x squared plus twice x in the denominator of the first term, then we have 1 upon x squared plus 6x plus 8, then we have 1 upon x squared plus 10x plus 24, and we bring that fourth term 1 upon x square plus 14x plus 48, and sum of all these four fractions is equal to 1 upon 5. Okay, so let us see if we can factorize each of these terms in the denominator. Okay, so the first term becomes x square plus twice x, so it is x times x plus 2. The second term, it is product is 8 and sum is 6, so 8 is 4 plus 2, right? So we can write it as x plus 2 times x plus 4. Then we have 10x, sum is 10 and product is 24, so this can be written as 4 plus 6, right? So this is x plus 4 times x plus 6. And then we have sum 14 and product is 48. 48 is 12 times 4, 6 times 8. Okay, 6 times 8, so this is x plus 6 times x plus 8, and this equals to 1 upon 5. Okay, so if we look carefully in the denominator, we see this is x times x plus 2. The next fraction in the denominator, it is x plus 2 times x plus 4, so 2 is added in each of these individual pairs in the product. It seems like x plus 2, the two terms is added, x then x plus 2, then we have x plus 2 comma x plus 4, then next pair has x plus 4 x plus 6, after that x plus 6 times x plus 8. Okay, so the difference is 2. X plus 2 minus x is 2, x plus 4 minus x plus 2 is 2 again. So we see the differences are 2 in each of these terms of the individual factors in the denominator. Okay, so what happens if we just try to resolve it into partial fractions? Okay, what if we write it x plus 2 minus x upon x times x plus 2? Okay, if we write it like this in the numerator, we see 2 will be left, whereas it was 1 here. Okay, so in order to keep it as it is, we have to multiply it with half. Okay, so the 2 in the numerator would get cancelled with this half. Okay, so this is the first term. The second term, again, if we write it as x plus 4 minus x plus 2, x plus 2 times x plus 4. Again, the differences in the numerator is 2, right? But we have 1 here. So in order to make it 1 again, we have to multiply it with half. Okay, so half times 2 will give us 1 again. Similarly, for the third term, if we subtract x plus 6 minus x plus 4 upon x plus 4 times x plus 6. Okay, we have to multiply with half again, since 2 will come in the numerator. And for the last term again, if we write x plus 8 minus x plus 6 upon x plus 6 times x plus 8, again 2 will come, so we have to multiply it with half because it was 1. here, right? Okay, so this is equal to 1 upon 5. So in all the terms in the LHS we have a half common, so we can take half outside. Okay, so we take half outside. Now if we divide this, if we split this fraction, okay, of these individual terms in these brackets, we see x plus 2 divided by this x times x plus 2. This first term will become 1 upon x, right? And the next term, this x and x will get cancelled and we will be left with 1 upon x plus 2. This is just the first term. Okay, similarly the second term, if we divide this x plus 4, this x plus 4 will get cancelled and we have 1 upon this x plus 2 will be left out, right? So we have 1 upon x plus 2 minus, this time x plus 2 will get cancelled here, so we will be left with 1 upon x plus 4. Okay, so it seems like the terms are getting cancelled out. Say minus 1 upon x plus 2, next term is plus, so this will get cancelled out. Similarly in the third term, if we divide x plus 6 by this product, x plus 4 times x plus 6, we are left with 1 upon x plus 4, and this is plus, and the previous term is minus 1 upon x plus 4, so these two will get cancelled out. So the next term will be 1 upon minus 1 upon x plus 6, right? So the fourth term, here it will be x plus 8 will get cancelled, so we'll be left with plus 1 upon x plus 6, and the last term will be this x plus 6 will get cancelled out and it will 1 upon x plus 8. Okay, so we see a lot of terms are now getting cancelled out. Okay, we are left with this 1 upon x will be left out, and this last term minus 1 upon x plus 8, this will be left out. Okay, and this is equal to half. So if we open the bracket, this and this will get cancelled. Similarly, this and this will get cancelled, and minus 1 upon x plus 6 will get cancelled with this one. Okay, so we are left with, if I multiply both sides with 2, this half will get cancelled out. We are left with 1 upon x minus 1 upon x plus 8. Okay, and multiplying this 1 by 5 with 2, we get 2 upon 5. Okay, so this whole clumsy equation, after factorizing and resolving into partial fractions, it is now a lot less convoluted. It looks a lot easier and simple. Okay, so after taking the LCM, now in the denominator we have x plus 8, x plus 8 minus x in the numerator. In the denominator we have x times x plus 8, right? After taking the LCM, this is equal to 2 upon 5. So this gives us 8, and this is x square plus 8x, and this is equal to 2 upon 5. Okay, so this 2 and this 8 will get cancelled, 4 here. So this implies that this is x square plus 8x is equal to 20. Okay, so this implies the quadratic equation becomes x square plus 8x minus 20 equal to 0. Okay, so we were to find the product of all values of x satisfying the equation. Okay, so we can factorize it as this is minus 20, right? So minus 20 will be 10 minus 2. We can do it like that, like this will become x plus 10 times x minus 2. So the roots will be minus 10 and 2. Therefore, product of roots will be minus 20. Minus 10 times 2, minus 20. Okay, so this is the final answer. Alternatively, directly without factorizing it, if we compare this with ax square plus bx plus c equal to 0, okay, product of roots will be minus c upon a, right? And in our case, a is 1, b is 8, and c is minus 20, right? Sorry, product of roots, sorry, my bad. Product of roots is plus c by a, sum of roots is minus b by a. Product of roots is just c by a, right? So c is our minus 20 and a is 1, so directly you can compute it as product of roots equal to minus 20. Okay, from this equation directly without factorizing. Okay, so this is the final answer. Minus 20 is the answer. So we did not have to simplify this, like did not have to expand this equation, take the LCM like this, because the pairs in the denominator, they were equispaced, right? They were, the differences between the pairs was constant. It was a fixed difference, right? So in case of fixed differences, we usually try to resolve it into partial fractions, because the terms usually are alternatively getting cancelled out. Okay, if the differences were say 3 instead of 2, this will get cancelled out. The problem happens if the differences are not equidistant. Okay, so this is slightly tricky in that aspect. If you have to check out if the differences are equidistant or not. If these are equidistant, we can always resolve it into this partial fractions. Okay, so this is it. Okay, thank you.